Ladies and gentlemen, welcome to Lindorm Incorporated. I'd like to give a little resume over the generations of SediMeter instruments. This is the prototype that I made when I was a doctoral student at Uppsala University. Here it's deployed in the Bahamas and it measures the migration of this weed sand ridge back and forth during the tidal cycle. It has a detector of 16 optical backscatter detectors. This is the first commercial version made on license in Norway because I patented the instrument. And here you see the sensor that provides the user with a scan of the turbidity of the backscatter, and then the level can be calculated and interpolated based on that with high accuracy, much better accuracy than the distance between the detectors. It's possible to detect the additional removal of a single grain of sand. That's how good an idea you can get. And the purpose of this instrument, when I developed this for my doctoral thesis, was to detect the onset of sediment transport. Because when you do a sediment transport equation, it's very important to know when does sediment transport start, at what current velocity or wave velocity. Now, in 2007, I took over production here in Miami in Lindorm Incorporated. And this is the first commercial version that I made here, the SM2, second generation. It has a longer sensor and a smaller logger house. A few years later, 2013, the third generation came out. Much more mature in the technology. It has an integral battery, nothing you can open, but it has an underwater connector, so you simply connect a cable to charge it to get the data out, and you can deploy it as a standalone logger, same as this, or connected to cable, even a long cable, because this is RS485, so it can be kilometer long cables and get data in real time. You can also do telemetry using our SediLink radio modem, which has a built-in solar panel here and a radio, and connects. You can sit on a buoy and connect to the instrument on the bottom. Now, we added one thing in this, and that is a number 37 optical backscatter detector up here to measure the suspended sediment concentration. To get accurate readings, this has to be free of the holder tube. As you see, this one goes into a holder tube that's screwed down into the bottom first. But the holder tube introduces a bias in the readings. So to get an accurate turbidity reading of suspended sediment, you need to have this one above the holder tube. So you have to put on something here like electric tape to make it stick here in the holder tube. The problem with the optical backscatter detector is that although it is good for high sediment concentrations, high turbidity levels, like above 500 is very good, it's not so good for low turbidity levels, below 100. And oftentimes you're dealing like here with low turbidity levels. Which is why we now in the fourth generation have replaced the optical backscatter turbidimeter up here with nephelometric turbidimeters. Unable to decide whether to put in the ISO standard with infrared light, ISO 7027, or the US EPA standard with white light, we put in both. Plus we added a fluorescence meter that emits ultraviolet light 367 nanometers and measures the scattered white light here. So now we have an instrument that can measure efficiently both bedload transport, sedimentation, erosion, resuspension, and suspended sediment transport by measuring the near bottom suspended sediment concentration, which has a useful range of about 10 to 500 FTU. This is a good all-around instrument for sediment studies. However, we added a few more things to make it even better. We added an accelerometer. If the user puts this on a platform and lowers the platform from the surface, he doesn't know if it's falling over or not. He doesn't know what it's measuring because it's not deployed into the bottom. It's standing on top if it's on the platform. Therefore, we added an accelerometer. So if it falls over, the user will know. It measures the tilt. But it does one more thing. it doesn't take just one measurement, it takes 20 to 30 measurements depending on the setting. From each measurement, it measures the acceleration 20 to 30 times with a frequency of 10 Hertz as standard. This gives us an idea of the vibration, the shaking, what's going on. Because when there is a strong current or waves, the vortices that form around the circular object will make it shake. So we can use the accelerometer data as a proxy for energy level in the water, the energy that causes sediment transport. That is the same reason we had the Savonius rotor on this one. We now have the accelerometer to get an idea here. And it has one more feature. The accelerometer measures all the time, and it's programmed with a threshold. So if the acceleration goes above the set threshold, it will tell the instrument to take an extra measurement. That way we can always detect and get data from the strongest accelerometer events. To protect the memory from getting filled by, let's say it's shaking all the time, every time it takes an extra measurement, it raises the threshold one notch. And one more thing, the turbidimeter here to function has to be kept clean. In the third generation, we had an option we had another version actually with a mechanical cleaner. Mechanical cleaners in water with sediment swirling around is prone to failure. So here we replace the mechanical cleaner with ultraviolet LEDs that shine on this window surface to keep this clean. This part does not need to be so clean. It just needs to be prevented. We just have to keep the barnacles away, because a little bit of algae does not prevent this from functioning. Barnacles do. And there is a way to keep barnacles away, and that's to put a copper tape on the rear side of the holder tube. The Bernoulli flow around the sensor will keep the front free from barnacles pretty much. We tested it 2 months here in the worst possible conditions of Miami, and it worked. All the time we could measure the level of the bottom in spite of not having any anti-fouling protection per se on the front side of the sensor. Also, there is a vibrator up here, so the vibrator can shake off bubbles that sometimes form on the surface. So this instrument is now available along with the SM3, which may be more useful and adequate for certain environments, especially where the sediment concentration is very high, like tropical reservoirs and things like that. And by the way, some have been asking, what is a Lindorm? Well, a few of you may have seen the Ragnar Lothbrok series on TV, the Vikings series. Do you know why his name is Lothbrok? That's the name of his pants. They were made from wolf skin impregnated with tar. And he had those on when he went to kill a Lindorm, dragon. Lindorm is the Scandinavian word for dragon. So, welcome to visit our website lindorm.com.